Hello there. Today we'll be doing a first advanced graph problem. I think I know why they're called advanced graph problems now. They don't use the general formula to do the graph problem. You'll see soon. So this is a min cost to connect all points. In this particular problem, we're looking at multiple points and we're trying to find out how to connect all of these items together at the minimum cost. So that means basically having one line per an item, and also trying to find the least cost. Something we want to do maybe was try to be greedy. If we try to do that, we see that you can go from 0 to 4 to 1, and then 1 to will go to 3, and then this will go to 5. However, we don't want to move from here to here. So even though that will form a that will not form a cycle, that would cause us to have longer distance. But instead, we'll just throw everything into a heap at all the costs and the items that we have visited, and we just pop every distance out until we get all the visited. That's one way to do it. But after looking at a Neetcode solution where with prime algorithm, which you can find here in the solution section here as well, prime's algorithm, you can actually add items after you generate items in the min heap as you go along, so that you don't have to generate as many visited nodes, and you don't have to include them inside your min heap for faster traversal. So first things first, we build an adjacency list to see how we can connect all of these items to its neighbors. How we do that is using a for loop. This is a very interesting thing that we have I've seen to learn about. So what happens is that we're going to create a adjacency list using the number of items, number of points, num points. Let's call them points, equals lang points, since we're looking at points. So let's look at adjacency list, which is going to be equal to p, each point, and it's going to create an array for point in range num points. So with that, that's complete. So we're going to do for I in range num points, and what's happening here is that we're going to look at our first item, equals points I, and for j in range I plus 1 nums num points, and like you'll see soon that distance, we have x2 and y2 equals points j, and distance equals absolute value of x1 minus x2. We don't really care about which way we do this. It's absolute value, so it really doesn't matter all that much. Adjacency list of I dot append the distance and the node that we're pointing to from I, and we're gonna point it from j as well to I. So by doing this both ways, we get all the items. So how do we get all the items? Let's take a look. So once we have 1, and we point to 2, 3, 4, and 5, but at the same time, we point to 1 for each of these items, right? So what happens now? We're building this up. So 2 is going to be pointing to 3, 4, and 5, and this is going to be pointing to 2. And this is going to be pointing to 4 and 5, and this is going to be pointing to 3, because we're pointing to the opposite item. And then this is going to point to 5, and this is going to point to 4, and we're done. And we've pointed to all the items. Each item points to all of its neighbors. Pretty neat. I didn't think about it doing this way before, but I mean, now I can see how we can get all the items, all the neighbor items for each particular node because of the cross-pointing. So pretty neat. Hopefully we'll remember how to do how this works and why this works. The reason why it works is because we're pointing each item towards its adjacent item while we go through that particular item for 1 through 4. And yeah. Okay, very good. So now with that, we're going to do Prime's algorithm. So Prime's algorithm is basically, we're going to take each particular item in starting with 0, and find all its neighbors, throw them in the min heap, find the minimum item, get that item, put it in the visited, and oh, that means we need a visited. So total distance is equal to 0, and we're gonna need a visited, which is equal to set. And so once we have items, visited items, we found all the items, then we can end the loop. So we start with a heap of 0, 0, and we're gonna move forward from that 0, 0 item, because what this represents is that this represents the cost, the distance, and this represents the point 0. So let's go. So while length of visited is less than points, distance and the point is the first and negative next item is equal to heap pop min heap. Then if point is in visited, we're going to continue I'm getting tired, huh? That's okay, that's okay. So total distance plus equals the distance that was for this item, and we add the node. So how can we be so sure we can add this distance? Because it's a min heap and we're popping that's the minimum distance. If it gets past this visited item, that means it's not visited yet. Let's add this to the visited, and we can add all of its neighbors as well. So why are we adding all of its neighbors and the distance? So the reason why is we're building it out as we move along, so that we don't have to add all each item. So let's just continue. So now then we're just gonna pop the item in to our into our heap min heap. So min heap, heap q dot heap push min heap our item. So this is going to be our neighbor distance, and this is going to be our neighbor, I believe. Yeah. And then with that, we will complete our we'll traverse through all the items until we get all the visited items, and then we'll return the total distance. Point and point, run and submit. So as you can see, I've done this before, and that's why this looks a little bit too easy, but it's not a very fast solution. It looks like it's pretty slow, but what we've learned today is how to build up all the neighbors for each particular item using adjacency I and j, using one for loop. Very cool. And we used the prime algorithm, a algorithm which uses a min heap, and how we can build up the min heap as we progress through the items and remove the items, and so that we don't have to process items that are already in the visited. Yeah, it's great stuff. Very easy to understand, very easy to implement. Yeah, great stuff. Good code, good video from Neetcode. Take a look if it does to make even more sense of this particular problem. And I hope you learned something today. If you enjoyed the video, like and subscribe, and I will see you in the next one.